In 2011, a mining machine in northern Alberta cut through rock that had not seen daylight in over 100 million years. What came out did not look like a fossil. It looked like something that had died recently. A body preserved almost completely intact, covered head to tail in tightly interlocked armor plating, still holding its original structure, still carrying traces of the color it had in life. It had sunk to the bottom of an ancient sea and simply stayed there, untouched for over 100 million years. Nothing had taken it apart, and when it was alive, almost nothing could have. For a long stretch of Earth's history, that kind of protection was not a rare advantage. It was the standard. Armor was not something unusual. It was the dominant survival strategy on this planet for hundreds of millions of years. Entire oceans filled with animals that were effectively walking fortresses, predators that wore armor, hunting prey that wore armor, ecosystems built entirely around the logic of who could and could not be broken open. One creature from this era, a fish, carried a bite force powerful enough to crack through the armor of other armored animals. It was the apex predator of its world, feared across entire ocean systems, and then it was gone, not reduced, not replaced by something similar, just gone. That pattern repeats itself across hundreds of millions of years. Armor appears, it dominates, it reaches extraordinary levels of complexity and sophistication, and then, within what amounts to a blink in geological time, it disappears. Not because it stopped working, something else changed, and the animals that had spent millions of years perfecting the art of being indestructible had no answer for it. What was that change, and why did a strategy that worked for so long, across so many different worlds, ultimately fail everywhere it appeared? Tonight, we find out. Before we do, let me know in the comments, are you watching this to wind down, or are you here purely for the science? Either way, you're in the right place. If this is the kind of content you come back for, a like and a subscribe genuinely help keep it going. Now let's get into it. Imagine a calendar that does not belong to any human hand. A year that begins not with memory, but with the formation of oceans, the slow cooling of rock, the first quiet chemistry of life taking hold. January passes in silence, then February, then March, each month carrying spans of time so vast they erase any familiar sense of duration. Continents shift, atmospheres thicken, microscopic life drifts and divides, all without witness. By the time this calendar reaches mid-November, something new begins to appear. Not large, not yet dominant, but different. Bodies begin to harden. Surfaces that were once soft begin to carry structure, mineral, resistance. The first armored creatures enter the record here, late in the year, after almost everything else has already been set in motion. The remaining weeks pass with a kind of gathering density. Life becomes more varied, more elaborate, more physically present in the world. Oceans fill with forms that hold their shape, that leave impressions in sediment, that endure. By the final day of December, the page is crowded with activity, with motion, with interactions that resemble the living world as it is known now. Humans arrive at 11:58 in the evening. The entire span of recorded history, every city, every conflict, every moment ever written down, unfolds within the final 10 seconds before midnight. All language, all invention, all memory exists in that narrow space at the edge of the year, balanced just before the page turns. Set against this scale, the era of armored life stretches across the equivalent of 6 full weeks. Not a brief experiment, not a marginal detail, but a sustained presence that shaped ecosystems, determined survival, and defined the physical boundaries of life, for spans of time that resist comprehension. This story moves through three long passages. The first begins in the early oceans, where armor rises alongside the first true predators, establishing a balance between attack and resistance that will define life for hundreds of millions of years. The second unfolds through a series of losses, where the dominance of armor begins to thin, retreating across changing landscapes and shifting climates. The third follows what remains, the fragments that persist into the present, adapted to narrower spaces, quieter environments, and different rules. At the center of all of it sits a single constant: armor worked. It worked across different worlds, under different conditions, against different threats. It endured through extinctions, through environmental upheavals, through cycles of loss and recovery. It was not a flawed strategy, nor a temporary one. It was one of the most successful solutions life ever produced. The question that follows is not about its effectiveness, but about the world that surrounded it. Something altered the conditions under which armor had thrived, something that did not simply challenge it, but made its advantages less certain, less reliable, less sufficient. The fossil record preserves this history with unusual clarity. Hard structures resist decay, hold their form, and settle into layers of stone where time moves slowly. The remains of armored creatures are not rare interruptions in the rock, but a constant presence, a repeating pattern that can be traced across continents and eras. And then, without gradual transition, the story reaches its beginning. Around 538 million years ago, within a span of time, brief enough to appear almost instantaneous on this scale, the oceans changed. Life did not simply continue, it accelerated, diversified, and reorganized itself in ways that would define everything that followed. For most of Earth's history, life unfolded without pursuit. Cells divided, drifted, absorbed energy from light or chemistry, and passed quietly through cycles of growth and decay. There was movement, but not intention. There was contact, but not conflict in the way later life would come to know it. The living world existed as a vast, slow exchange where survival depended more on persistence than on escape. Then, within a narrow interval of deep time, that balance shifted. Around 538 million years ago, the oceans began to record a different kind of interaction. Not gradual, not tentative, but immediate. Bodies appeared that were shaped not just to exist, but to act upon other bodies. Structures formed that could grasp, tear, crush. The fossil layers from this interval do not suggest a slow transition. They present a sudden density of new forms, each carrying unfamiliar geometries, unfamiliar intentions. This period, often described as the Cambrian explosion, unfolds across roughly 20 million years, a brief moment when set against the vastness that surrounds it. Within that span, nearly every major body plan that defines animal life emerges. Limbs, eyes, digestive systems, segmentation, all appearing in overlapping waves, as though life had found a new set of rules and began exploring them all at once. One explanation settles quietly beneath this transformation: the arrival of the first true predators. The moment an organism could actively seek out another, track it, and consume it, the entire structure of life shifted. Survival was no longer only about endurance or reproduction. It became entangled with awareness, movement, and response. Among the creatures that carried this change forward was Anomalocaris, a form that moved through Cambrian waters with a presence unlike anything before it. Its body reached lengths of up to 1 meter, guided by large compound eyes composed of thousands of individual lenses, each contributing to a wide and detailed field of vision. At its front, flexible appendages curved inward, directing food toward a circular mouth lined with hard plates that rotated and pressed together. The evidence of its activity remains preserved in stone. In deposits such as the Burgess Shale, trilobite shells carry distinct patterns of damage, fractures that match the form and force of Anomalocaris feeding. These marks are not abstract traces. They are records of encounters, moments where one organism overcame another, leaving behind a physical memory that endured across 500 million years. Elsewhere in these same sediments, a different kind of experiment appears. Hallucigenia, a small creature with a body lined by elongated spines, presents a form so unfamiliar that its orientation puzzled researchers for decades. What were once interpreted as legs were later understood as defensive projections, rigid structures extending outward, altering how other organisms could approach or grasp it. The ocean during this time became a layered environment of interaction. Movement gained direction, surfaces gained purpose, and space itself became structured by the presence of threat and response. Creatures no longer occupied the water passively. They navigated it, responded to it, and increasingly to each other. This shift did not remain confined to a single lineage or region. It spread through the living world, reshaping bodies and behaviors in ways that would echo across all subsequent history. The earliest predators established a condition that could not be reversed. Once introduced, the possibility of being hunted became a permanent feature of life. From that point forward, every form carried some relationship to this new reality, whether through speed, concealment, or the first attempts at physical defense. They arrive in the record without hesitation, already complete. There is no visible prelude, no gradual shaping across earlier layers. Around 521 million years ago, trilobites appear as if they had been preparing elsewhere, entering the oceans fully formed, carrying a design that required no introduction. Their bodies are built from calcite, a mineral that settles easily into stone long after life has left it. This material forms a segmented exoskeleton, each section connected with quiet precision, allowing movement without sacrificing strength. In some species, the eyes themselves are constructed from calcite, lenses arranged in crystalline arrays that bend light through mineral rather than tissue. Vision passes through stone before reaching the inner structures that interpret it. Across the ancient oceans, this body plan unfolds into a remarkable range of forms. Some trilobites measure no more than a millimeter, drifting close to the seabed, their presence barely disturbing the fine sediment beneath them. Others extend to lengths of 72 centimeters, moving with slow authority across the ocean floor. Some sift particles from the water, filtering nutrients from passing currents. Others navigate deeper regions where light fades and pressure increases, adapting their structure to environments that offer little stability. Each variation remains anchored to the same fundamental architecture, a central axis, flanked by articulated segments, protected by a continuous dorsal surface. The simplicity of the plan allows it to stretch into different roles without losing its coherence. It is not a rigid form, but a flexible template capable of adjustment without reinvention. When threatened, many trilobites perform a movement that transforms their entire body into a single defensive shape. The segments fold inward, the head and tail meeting in a precise alignment, forming a compact sphere. In certain species, small interlocking structures along the edges engage as the body closes, securing the shape so tightly that external force cannot easily separate it. The soft underside disappears entirely, sealed within a mineral enclosure that distributes pressure evenly across its surface. Some forms extend this protection outward. The genus Redlachia develops elongated spines that project laterally, increasing the apparent size of the body and complicating the approach of any organism attempting to grasp it. These projections alter the geometry of interaction, turning a smooth surface into something irregular, difficult to handle, resistant not only through strength but through form. Through changing oceans and shifting climates, trilobites persist. They pass through the late Ordovician extinction, when marine environments contract and reorganize. They continue through the late Devonian, where ecosystems undergo prolonged disruption. Smaller events ripple through the oceans, altering conditions in ways that challenge many lineages. Trilobites remain present through all of them, adjusting in distribution and diversity, but maintaining their essential structure. The span of their existence extends across 270 million years. When placed beside more familiar intervals, the scale becomes difficult to hold. The time since the disappearance of the large dinosaurs measures 66 million years, a duration that already stretches beyond ordinary reference. Trilobites occupied the Earth for more than 4 times that length, their presence woven through layers of rock that accumulate across continents. Their forms become so common in the fossil record that entire strata are defined by their remains. Shells settle, are buried, and harden into stone, repeating across vast regions. The pattern of their existence becomes part of the structure of the planet itself, a quiet accumulation of mineralized life. And then, near the close of the Permian period, the continuity ends. Across all environments, in every region where they had once been present, trilobites disappear entirely. The structure that had endured for so long, refined across uncounted generations, leaves no continuation beyond that boundary. Inside a block of ancient rock, a pattern appears that does not belong to stone alone. Fragments of bone lie clustered together, not scattered by currents or time, but arranged in a way that suggests they once passed through a living body. They are not complete skeletons. They are heads, partially broken down, their surfaces worn by digestion, yet still recognizable as armored forms. These remains are not from the animal itself, but from what it consumed. They belong to other armored fish, creatures that carried their own protection, their own carefully formed defenses, yet found themselves inside something capable of overcoming all of it. The fragments remained undigested, too dense to be fully broken apart, eventually expelled and left to settle into sediment, where they would remain for roughly 370 million years. The animal responsible for this trace is Dunkleosteus terrelli. Its full length reached between 8 and 9 meters, a body extending through the water with a presence that did not rely on speed alone. Its defining feature was not size, but structure. Where most predators carry teeth, Dunkleosteus possessed sharpened bony plates, growing continuously along the edges of its jaws. Each time the mouth closed, these plates ground against one another, maintaining a cutting surface that never dulled. The force produced at the tips of these blades has been estimated at 4,400 newtons. This level of pressure concentrates along narrow edges, allowing the animal to slice through dense material with efficiency. The prey it encountered did not simply resist, it fractured. The motion of its jaws added another dimension. The mouth could open in a fraction of a second, approximately 1/50th, creating a rapid expansion of volume that displaced the surrounding water. This movement generated a sudden inward flow, drawing nearby organisms directly toward the opening. Distance offered little protection, as the water itself became a medium of capture. Dunkleosteus belonged to a larger lineage known as the Placoderms, a group of early vertebrates that developed a distinctive form of armor. Their bodies were not covered uniformly. Instead, thick plates of bone formed a protective casing around the head and upper torso, joined by articulated connections that allowed controlled movement. The rest of the body extended behind this shield, more flexible, more mobile, but still integrated into the overall design. The jaw mechanism of these animals differed from later fish. Rather than simply lowering the lower jaw, the upper portion of the skull lifted as well, opening along a hinge that redefined the shape of the head during feeding. The entire front of the body participated in the act, creating a wide forward facing opening that could accommodate large prey. Across the Devonian seas, Placoderms occupied a wide range of roles. Some moved along the seabed, processing organic material within the sediment. Others filtered particles from the water, while certain forms adopted active predation. This diversity allowed the group to spread across environments, forming a dominant presence that lasted for tens of millions of years. Among them, smaller species such as Bothriolepis developed jointed fins capable of supporting limited movement across soft substrates. In shallow waters that fluctuated with seasonal drying, these structures may have allowed brief excursions across exposed surfaces, carrying their protective plates into spaces where water receded. The system as a whole represents a peak in the development of armored vertebrates. Protection, mobility, and feeding capacity align within a single framework, refined through long intervals of evolutionary adjustment. And yet, within the layers that follow, this entire lineage disappears. The forms that once filled these waters, from the smallest bottom dwellers to the largest predators, leave no continuation beyond a narrow boundary in time. On land, something quiet begins to take hold. It does not move with intention or pursue anything in its path. It grows upward and downward at the same time, extending into the air while reaching deep into the ground. The first true forests rise during the Devonian period, forming networks of trunks and roots that alter the surface of the planet in ways that had not occurred before. These early trees do more than occupy space. Their roots press into rock, widening fractures, breaking apart mineral structures that had remained intact for vast stretches of time. As this material loosens, it does not remain where it formed. Rain carries it into streams, streams into rivers, and rivers into the shallow seas that border the land. The substances released are small in scale but immense in effect. Phosphorus and nitrogen, once locked within stone, now enter the water in continuous flow. These nutrients feed microscopic life, allowing algae to grow at rates that exceed the balance the ocean had maintained. The surface layers become dense with organic matter, spreading outward in broad, slow expansions. As these blooms increase, they begin to change the chemistry of the water itself. Oxygen, once freely available throughout the upper layers, becomes limited. The process unfolds gradually, not as a sudden loss, but as a steady consumption. Microorganisms breaking down the excess organic material use oxygen faster than it can be replaced, leaving behind regions where little remains. In these areas, movement continues, but the conditions that support it begin to narrow. Organisms adapted to stable oxygen levels encounter environments where each breath becomes less certain. The shallow tropical seas, once filled with activity, begin to fragment into zones where life can persist and zones where it cannot. This transformation does not occur in a single moment. It extends across millions of years, marked by repeated intervals of disruption. Two of the most significant phases, known from the layers they leave behind, are separated by roughly 10 million years. Each interval brings a collapse of ecological structure, followed by partial recovery, then another shift, creating a prolonged period of instability. Within this extended transition, the dominant forms of the Devonian Ocean begin to disappear. The placoderms, which had filled a wide range of ecological roles, leave no continuation beyond this boundary. Their presence, once distributed across many environments, contracts until it vanishes entirely from the record. Other lineages persist, though altered. Eurypterids, large arthropods that had occupied predatory niches, continue in reduced diversity. Trilobites remain as well, but their forms become less varied, their distribution more limited than before. In the spaces that open, different organisms expand. Sharks and early bony fish increase in number, their bodies structured with less reliance on heavy external protection. Along the margins of the water, the first vertebrates, capable of moving onto land, begin to appear, carrying limbs that support weight beyond buoyant environments. The pattern that emerges reflects a shift in what the environment can sustain. The extensive mineral structures that once defined many marine organisms become less compatible with conditions where resources fluctuate and oxygen availability cannot be assumed. The forests continue to grow throughout this time, spreading across landscapes, deepening their influence on the cycling of materials between land and sea. What appears stable on the surface carries consequences that extend far beyond the boundaries of the land itself. The oceans that follow no longer resemble those that preceded them. The distribution of life changes, the dominant forms shift, and the balance between protection and mobility begins to favor different solutions. The extensive armored systems that once defined entire ecosystems do not return in the same way within these waters. The surface of the land begins to carry a different kind of movement. It is slower than the currents that once guided life, heavier in its contact with the ground, shaped by gravity in ways that water had long softened. Early attempts to inhabit this space had already taken place. Brief excursions, partial adaptations, bodies that could endure exposure for short intervals. Yet after the long changes in the oceans, a more sustained presence begins to unfold. On land, protection acquires a new cost. In water, mass is supported, its burden distributed by the surrounding medium. On land, every structure must be carried directly, supported by limbs, balanced through motion. A layer of mineral that once pressed lightly against the body becomes a continuous weight, present in every step, every pause, every attempt to move. The response to this constraint does not abandon protection, but reshapes it. Instead of forming a single, continuous covering, bone begins to develop within the skin itself, emerging in discrete elements. These structures, known as osteoderms, spread across the body in patterns that follow its movement. Each piece forms independently, yet aligns with its neighbors, creating a surface that can resist force while still bending where necessary. This arrangement allows the body to retain mobility. Joints remain free to articulate, muscles can expand and contract beneath the surface, and the overall mass is distributed rather than concentrated. Protection becomes something that conforms to motion rather than restricting it, a network rather than a shell. Among the earliest large animals to carry this system fully are the parasaurs. They appear during the Permian period, occupying landscapes that shift between arid stretches and more stable regions of vegetation. Their bodies are broad and substantial, supported by limbs that extend downward rather than outward, positioning them directly over their weight. The surface of their skin carries a pattern of raised bone, knobs and plates embedded across the dorsal side, forming a textured barrier that alters both appearance and function. Some individuals reach sizes comparable to large modern herbivores, moving slowly across the terrain, their mass balanced by a low center of gravity. The arrangement of their bodies makes overturning them difficult, their width and stance creating stability against external force. One form, known as Scutosaurus, presents this design with particular clarity. Its dorsal surface is covered extensively in osteoderms, each element contributing to a continuous protective field. The body remains low, the head held forward, the limbs positioned to bear weight efficiently. The overall shape is not streamlined for speed but for endurance, for maintaining position rather than escaping it. In the same environments, another presence moves with a different intention. Gorgonopsids, predatory therapsids, develop a mode of hunting that emphasizes sustained movement. Their bodies are structured for pursuit, limbs aligned for forward motion, jaws equipped with elongated teeth capable of penetrating softer regions of their prey. Their approach is not confined to sudden encounters. It extends across distance, following movement, applying pressure over time. This introduces a dynamic that will persist across the history of land animals. Protection through mass and structure provides resistance against immediate attack, particularly from predators that rely on force applied at close range. Movement, speed, and endurance offer a different form of response, one that avoids contact altogether. These two strategies do not replace one another. They exist together, each shaping the other, each defining the conditions under which the other must operate. The landscapes of the Permian carry both forms, bodies that stand and bodies that pursue, each refining its own approach within the limits imposed by the environment. The patterns established here will echo forward, reappearing in different lineages, under different conditions, but guided by the same underlying constraints. Far to the north, the ground begins to open. It does not break all at once. It spreads slowly, fissures extending across a landscape that stretches farther than any horizon could hold. From these openings, molten rock rises and pours outward, covering layer upon layer of the surface. This is not a single eruption, but a sustained outflow, continuing across spans of time that outlast generations of any living thing. The region now, known as the Siberian Traps, expands until it covers an area comparable to an entire continent. Lava accumulates in vast sheets, cooling, then replaced by more, building a sequence of rock that records a process lasting close to 1 million years. Along with the molten material, gases escape into the atmosphere, carbon dioxide in immense quantities, sulfur dioxide in volumes sufficient to alter the chemistry of air and water. As these gases disperse, the temperature of the planet begins to rise. The increase is gradual in its onset, but persistent. Over time, global conditions shift by around 10 degrees Celsius, enough to transform climates, disrupt weather patterns, and alter the balance between land and sea. At the same time, sulfur compounds dissolve into the oceans, lowering their pH, creating conditions that challenge the stability of many biological structures. Within the water, another change unfolds. Oxygen levels decline, not uniformly, but across expanding regions where circulation slows and consumption increases. Layers of the ocean become depleted, then deprived, creating environments where most forms of complex life cannot persist. These anoxic zones deepen and spread, forming what is sometimes described as a Canfield Ocean, a state in which vast volumes of water carry little to no oxygen. Life retreats into narrower spaces, constrained by conditions that no longer support its previous distribution. The margins between survivable and uninhabitable environments shift continuously, leaving little stability for organisms adapted to more constant conditions. The losses accumulate across both sea and land. Marine species diminish until approximately 96% are gone. On land, around 70% of vertebrate species disappear. These are not reductions, that leave behind diminished populations. They represent entire lineages ending, leaving no continuation beyond this boundary. Among those lost are the long-standing inhabitants of earlier worlds. Trilobites, present through multiple cycles of change, do not persist beyond this point. Their presence, once embedded across layers of rock, ends within the shallow seas where they had remained for so long. Eurypterids, the large arthropods that moved through ancient waters, also vanish. On land, the parasaurs and their relatives, including forms such as Scutosaurus, disappear from the record as well. The pattern is not selective in a simple sense. It does not remove only the weak or the poorly adapted. It alters the conditions so extensively that the traits which once supported survival become insufficient. Structures that required stable resources, consistent oxygen levels, or specific environmental conditions can no longer be maintained. Across the planet, the continuity of life narrows to those forms capable of enduring fluctuation, scarcity, and prolonged stress. These survivors are not defined by size or dominance. They are characterized by flexibility, by the ability to persist with minimal input, to endure intervals where the environment offers little. Recovery begins slowly. Over roughly 10 million years, ecosystems reassemble, not by restoring what was lost, but by building new arrangements from what remains. The forms that emerge carry different balances, different priorities, shaped by the conditions that allowed them to persist. Within this altered world, the presence of extensive armor becomes rare. The lineages that once embodied it across oceans and land have ended, leaving only distant possibilities within the descendants that continue forward. The outline of a turtle does not immediately reveal how unusual it is. It appears simple at first, a rounded form moving slowly, its body enclosed within a continuous surface. Yet, beneath that surface lies a structure unlike any other among vertebrates, a design that required the body to reorganize itself in ways that no other lineage attempted. In most animals, protective coverings sit outside the core framework of the body. Shells, scales, or plates develop around an internal skeleton, forming a boundary between the organism and its surroundings. In turtles, that boundary is not external. It is the skeleton itself, reshaped, expanded, and repositioned until it becomes the surface of the body. The ribs, which in other vertebrates curve inward to support the torso, broaden and extend outward, flattening into wide plates. These plates fuse together, forming the upper portion of the shell, known as the carapace. The spine attaches directly to this structure, becoming part of a rigid dome that encloses the body from above. At the same time, the shoulder blades shift inward, moving inside the ribcage rather than remaining outside it. This reversal places the limbs within a framework that would normally surround them, altering the arrangement of muscles and organs in a way that requires precise coordination during development. The lower portion of the shell, the plastron, forms from additional bony elements, completing the enclosure from below. This transformation does not occur abruptly. It unfolds across a long sequence of intermediate forms, each carrying partial elements of the final structure. Fossils such as Odontocheles, Semitestacea preserve one stage of this process. This animal possesses a fully developed plastron protecting the underside, while the upper shell remains incomplete, represented by broadened ribs that have not yet fused into a continuous surface. Later forms, including Eorhynchus and Progonocheles, appear with the full configuration already in place. Their bodies carry a complete shell, indicating that the preceding transformations, spanning tens of millions of years, had reached a stable outcome. By around 220 million years ago, the turtle body plan exists in a form that will persist with remarkable consistency. The consequences of this design extend beyond protection. The rigid enclosure limits flexibility, constraining movement in ways that differ from other vertebrates. Breathing, for example, cannot rely on the expansion and contraction of the rib cage. Instead, turtles develop alternative mechanisms, using muscles attached to internal structures to move air in and out of the lungs. Despite these constraints, the design proves durable. Across changing climates, shifting continents, and multiple extinction events, turtles continue to occupy a wide range of environments. Freshwater systems, marine habitats, and terrestrial landscapes all host forms that retain the same fundamental structure, adjusted in detail but unchanged in principle. The persistence of this body plan suggests a balance between cost and function that remains viable across long spans of time. The shell provides a level of protection integrated directly into the body's framework, reducing reliance on additional structures while maintaining structural integrity. Through the extinction that ended the age of large reptiles, through periods of global cooling and warming, through the expansion of new dominant groups, turtles remain present. Their form, established deep in the past, continues forward with minimal alteration, carrying with it the record of a transformation that redefined what a vertebrate body could become. Across the closing chapters of the Cretaceous, the land carries a form that appears almost complete in its purpose. Its body sits low to the ground, wide and steady, each step measured, each movement supported by a structure that seems to anticipate force from every direction. Ankylosaurus magnaventris reaches lengths of around 8 meters, with a mass that can approach 8 tons. Its entire upper surface is covered in osteoderms, dense plates of bone arranged in patterns that combine rigidity with controlled flexibility. Some sections fuse into continuous shields, forming a near-solid covering along the back, while others remain articulated, allowing the body to move without breaking the integrity of its protection. The surface is not smooth. It carries ridges, protrusions, and layered textures that disrupt the application of pressure. Any bite that lands does not meet a uniform plane, but a complex arrangement of angles and thicknesses. Fossil evidence shows tooth marks left by large predators, impressions that fail to penetrate, remaining as shallow traces across an otherwise intact surface. At the rear of the body, the tail extends into a structure that functions as both deterrent and weapon. The vertebrae near the end fuse together, forming a rigid support for a mass of bone at the tip. This club can be swung laterally, driven by the movement of the hips and the stiffness of the tail, delivering impacts capable of fracturing the limbs of approaching animals. The force generated during such a strike is substantial, concentrated into a compact area that transfers energy directly into whatever it contacts. In the same environments, large theropods move with a different set of capabilities. Among them, Tyrannosaurus rex carries a skull adapted for delivering powerful bites, its teeth designed to crush and tear. These animals share the same landscapes as Ankylosaurus, their paths intersecting within the same ecosystems. The record preserves encounters between them, not as complete events, but as marks left on bone, indications of attempts that did not succeed. Despite this extensive protection, another detail emerges from a related discovery that alters how this body is understood. A specimen of a nodosaur, a close relative within the same broader group, was found preserved with unusual completeness. Analysis of its surface reveals pigmentation patterns consistent with countershading, a distribution of darker tones along the upper body and lighter tones below. This arrangement reduces visual contrast, allowing the animal to blend more effectively with its surroundings. It is a form of concealment, one that alters how the body is perceived against the background of its environment. The presence of this pattern indicates that even an organism carrying substantial armor did not rely on protection alone. The implication extends beyond a single species. The structure of Ankylosaurus suggests a similar need to manage visibility, to exist not only as a fortified presence, but as one that remains less easily detected. The armor provides a response to direct contact, a way to withstand force once it is applied. It does not prevent the approach itself. Within this combination of strength and concealment, a boundary becomes visible. Protection can address the moment of impact, but it cannot fully remove the conditions that lead to it. The environment remains filled with movement, perception, and interaction, elements that operate before any physical encounter occurs. The body of Ankylosaurus represents one of the most extensive developments of external defense in terrestrial life. It integrates mass, structure, and mechanics into a system that resists direct attack with remarkable effectiveness. Yet within that system, the presence of visual adaptation suggests an awareness, not in thought but in form, that survival involves more than resisting force. A single body rests within stone, not flattened into a trace, not reduced to fragments, but held in 3 dimensions as though time had passed around it without altering its form. The contours of skin remain, the arrangement of scales preserved, the boundaries between each plate still defined with unusual clarity. This animal, Borealopelta, lived around 110 million years ago. At the end of its life, it did not remain on land. Water carried it outward, moving it away from the environment it had occupied into a marine setting where the conditions differed in quiet but important ways. It descended through the water column and reached a seabed where oxygen was scarce, a place where decay slowed and disturbance remained minimal. Sediment covered the body rapidly. Layers accumulated before the structure could collapse, enclosing it within material that would later harden into rock. The result is not a typical fossil, but something closer to a preserved form, retaining surface detail and spatial relationships that are rarely maintained over such spans of time. When the rock surrounding it was opened in the early 21st century, the appearance of the specimen led to initial uncertainty. The texture of the skin, the continuity of the armor, and the overall integrity of the body suggested something far more recent. Only closer examination revealed its age, placing it deep within the Cretaceous. Within the preserved form, the contents of the digestive system remained intact enough to be studied. Analysis revealed a mixture of plant material, including ferns and cycad leaves, arranged in a pattern that reflects recent feeding. Among these remains, small fragments of charcoal were also present, indicating that the vegetation consumed had grown in an area affected by fire. This detail suggests selectivity rather than randomness. The animal was not simply consuming whatever was available. It was choosing specific plants within a regenerating landscape, interacting with its environment in a way that reflects both awareness and preference. The presence of charcoal places it within a cycle of disturbance and regrowth, where new vegetation emerges following burning events. The surface of the body carries another layer of information. Pigment structures within the preserved skin reveal a distribution of color that follows a gradient, darker along the upper surfaces and lighter below. This pattern reduces visual contrast, blending the body into its surroundings when viewed from different angles, a strategy that affects how it is perceived within its environment. The mass of this animal approaches 1,300 kilograms, a substantial presence, yet the combination of color and form indicates a reliance on remaining less visible. Protection is not limited to resisting force. It includes reducing the likelihood of being approached in the first place. Within the same environment, other organisms move with different capabilities. Among the potential predators, Acrocanthosaurus occupies a position defined by strength and reach. Its limbs, more robust than those of later large theropods, may have allowed it to interact with prey in ways that extended beyond simple biting, applying force to manipulate or reposition its target. For an animal carrying extensive dorsal armor, such interactions introduce a point of exposure. The underside, where flexibility must be maintained for movement and internal function, remains less protected. The preserved body of Borealopelta does not show direct evidence of such an encounter, yet its form reflects the balance between protection and vulnerability that shaped its existence. Seen from above, many armored bodies appear complete. Their surfaces curve outward in continuous lines, plates meeting plates, edges overlapping in ways that leave little exposed. The geometry suggests closure, a form that has resolved the problem of contact from every direction. Yet the lower surface tells a different story. Across distant oceans and later across land, the underside remains a place where protection thins or disappears. This pattern does not belong to one lineage or one moment in time. It repeats across forms that share no direct ancestry, appearing wherever armor develops as a response to pressure from the outside. In trilobites, the underside carries the structures required for movement and respiration. Legs extend downward, delicate compared to the mineral layers above. Gills operate along this surface, exchanging gases with the surrounding water. These functions require space and flexibility, conditions that solid armor would restrict. The dorsal surface bears weight and force, while the ventral side remains open enough to sustain life. In placoderms, heavy plates cover the head and upper body, forming a rigid front that can meet impact directly. Beneath this, the body transitions into softer tissues, protected by scales rather than solid bone. This arrangement allows motion to continue, permitting the animal to swim with coordination while maintaining a defended anterior. On land, the same distribution appears again. Ankylosaurs carry dense osteoderms across their backs, forming an almost continuous barrier against attack from above or the side. Their undersides, though reinforced with thick skin, lack the same bony coverage. The need for movement, for the expansion of lungs, for the function of internal organs, prevents the extension of rigid structures across this region. Glyptodonts, distant in lineage yet similar in outward form, develop a domed carapace that encloses the upper and lateral surfaces of the body. Beneath that dome, the underside remains comparatively soft, structured for flexibility rather than resistance. Even in turtles, where the shell forms a more complete enclosure, the lower portion differs from the upper. The plastron provides coverage, but its shape and thickness do not match the curvature and strength of the carapace above. The reason lies within the arrangement of the body itself. The ventral surface is where muscles anchor, where limbs connect, where organs expand and contract. Movement depends on these interactions, on the ability of tissues to shift and respond. A continuous rigid layer across this region would interfere with basic functions, limiting the animal's capacity to walk, to breathe, to process food. Because of this, every armored form carries an asymmetry. The upper surface can be reinforced extensively, shaped to resist compression and impact. The lower surface must remain adaptable, able to accommodate the internal demands of the organism. This difference is not a flaw introduced late in development. It is present from the beginning, embedded in the constraints that shape how bodies are built. Predators interact with this structure over time. Fossil evidence suggests patterns in how attacks are directed. In some Permian ecosystems, injuries on large herbivores indicate contact from below, near the junctions where limbs meet the body. In later periods, marks on armored dinosaurs concentrate toward areas where protection transitions, where rigid plates give way to more flexible regions. These interactions do not require immediate precision. Over long intervals, repeated encounters favor those approaches that yield results. The distribution of force, the angle of contact, the persistence of pursuit all contribute to how pressure is applied to the armored body. In response, armor becomes more extensive, more integrated, more complex in its arrangement. Plates increase in thickness, edges interlock more tightly, coverage expands across additional regions. Yet the lower surface cannot be fully transformed without altering the functions that sustain the organism. Within this balance, a limit emerges, not as a single boundary, but as a gradual threshold. Protection can extend only as far as the body allows before it begins to interfere with the processes that keep the animal alive. There is a point in the life of any organism where balance begins to narrow, where the structures that ensure survival demand more than the environment can quietly provide. It is not a sudden failure, but a gradual tightening, a shift in which each day requires slightly more than the one before. In armored bodies, that demand is written in mineral. Bone is not a passive material. It must be grown, repaired, and sustained through a continuous flow of resources. Calcium and phosphate must be gathered from food, processed within the body, and deposited in precise arrangements that maintain both strength and function. This process does not end once the structure is formed. It continues throughout the animal's life, countering the constant cycle of breakdown and renewal that affects all living tissue. For large armored animals, this cost accumulates. A fully grown ankylosaur carries several hundred kilograms of dense bone across its back and sides. Each segment of that structure represents stored material, energy that has been taken from the environment and fixed into the body. The armor must be supported by muscles, moved with each step, and maintained against the natural processes that gradually weaken it. When conditions remain stable, this system holds. Abundant vegetation provides the necessary nutrients, allowing the body to sustain both its basic functions and its protective structures. The presence of predators reinforces the value of this investment, as the armor reduces the likelihood of fatal encounters. When conditions begin to shift, the balance changes. Food becomes less predictable, plants diminish in quantity or quality, and the steady input of minerals declines. In these moments, the body does not abandon its internal processes. It reallocates resources, drawing upon what it has already built. Bone, despite its strength, remains a reservoir. The body can extract calcium from it when needed, redirecting it toward essential systems that cannot be compromised. As this process continues, the integrity of the armor weakens. What was once a protective layer becomes thinner, less capable of absorbing force, its effectiveness reduced from within. This dynamic does not operate in isolation. It appears most strongly during periods when ecosystems undergo broader disruption. Mass extinctions, rather than acting as indiscriminate events, apply specific pressures that favor certain traits over others. Extended intervals of reduced primary productivity, where plant life declines or becomes unstable, create conditions in which high-cost structures become difficult to sustain. Across multiple extinction events, a pattern emerges. Armored lineages, particularly those with extensive mineral investment, decline or disappear. The late Devonian, the Permian transition, and the boundary at the end of the Cretaceous each involve disruptions to food chains that extend over long periods. In these contexts, the capacity to endure scarcity becomes more significant than the ability to resist direct attack. Organisms that survive these intervals share a different set of characteristics. Their bodies require less continuous input. Their metabolic rates allow for extended periods of reduced activity, and their structures do not depend on large quantities of stored mineral. Crocodilians can remain without food for months. Turtles maintain low energy demands, and small mammals adjust their activity to match available resources. In contrast, heavily armored animals carry a burden that cannot easily be reduced. Their protection is tied to a constant supply, a dependency that becomes visible only when that supply begins to fail. Over time, environments that once supported extensive armor become more variable, more prone to fluctuation. The conditions that allowed such structures to develop and persist grow less consistent, favoring forms that can adjust more readily to change. A shadow crosses the ocean long before anything touches the ground. It moves faster than any storm, faster than any current, descending through the upper atmosphere with a speed that compresses air into heat. Around 66 million years ago, a body of rock measuring between 10 and 15 kilometers across approaches the surface, traveling at roughly 20 kilometers per second. Its path ends in shallow water near what is now the Yucatan Peninsula. The contact is not a collision in the ordinary sense. It is an instantaneous release of energy, equivalent to billions of simultaneous detonations, concentrated into a single point. In the first moments, the surrounding region is exposed to temperatures that erase structure. Everything within a radius of approximately 1,500 kilometers is subjected to conditions that do not allow survival. Material from the impact site is driven upward with force sufficient to leave the atmosphere. Fragments of rock, droplets of molten material, and fine particles expand outward, forming a cloud that begins to encircle the planet. Within hours, this debris disperses across the upper layers of the atmosphere, reducing the amount of sunlight that can reach the surface. The effect is not immediate darkness, but a gradual dimming that intensifies over time. As particles remain suspended, they block incoming radiation, lowering temperatures across land and sea. The change does not resemble a brief seasonal shift. It extends across years, possibly decades, altering the conditions required for plant growth. Photosynthesis declines as light becomes limited. Plants, dependent on consistent energy input, begin to fail. As vegetation diminishes, the organisms that rely on it for food lose their primary resource. Herbivores decline, followed by the predators that depend on them. The structure of ecosystems unravels through these connections, each level dependent on the stability of the one below it. Within the fossil record, this transition appears with unusual clarity. Layers of sediment mark the boundary between what existed before and what follows. Below this boundary, the remains of large armored dinosaurs are present, their structures embedded within the rock. Above it, they do not reappear. Ankylosaurs, distributed across multiple regions, disappear entirely. Nodosaurids, close relatives with similar protective systems, are absent beyond this point. Other large herbivores, including ceratopsians and sauropods, also end within this interval, leaving no continuation into the layers that follow. In contrast, certain smaller or more flexible organisms persist. Birds, the descendants of earlier theropods, continue through this transition. Small mammals, along with reptiles such as lizards and snakes, remain present. Crocodilians survive within aquatic environments, and turtles persist with their enclosed body plan. Among these survivors, a shared characteristic becomes apparent. Their bodies require less continuous input from the environment. Crocodilians can reduce their metabolic activity, remaining without food for extended periods. Turtles operate with low energy demands, capable of sustaining themselves under conditions where resources are limited. Armor, as a structure, does not disappear entirely. It remains within these surviving lineages, though expressed differently, integrated into bodies that can endure prolonged scarcity. The large, heavily armored dinosaurs, dependent on stable and abundant food sources, do not persist under the altered conditions. As the atmosphere gradually clears and light returns, ecosystems begin to reorganize. The spaces once occupied by large herbivores and their associated predators become available to other forms. New lineages expand into these roles, adapting to conditions shaped by the aftermath of the impact. Within this restructured world, the balance between protection, mobility, and energy shifts again, setting the stage for forms that will develop under these new constraints. Far from the shifting continents of the northern world, a landmass drifts in long isolation. South America remains separated by ocean for much of the Cenozoic, its ecosystems developing along paths that do not intersect with those elsewhere. Within this separation, mammals expand into forms shaped by local pressures, filling roles that, in other regions, had already been defined by different lineages. Among these forms, Armour returns. The glyptodonts emerge around 20 million years ago, distant relatives of modern armadillos, yet transformed into something much larger and more enclosed. Their bodies carry a dome of fused osteoderms, forming a continuous shell that curves over the back and sides, extending downward to cover much of the lower surface. Unlike earlier terrestrial armor, which often retained segments or articulation, this structure is rigid, unified, and uninterrupted across broad areas of the body. The shell is composed of tightly packed bony units, each one interlocked with those around it, forming a surface that resists deformation. Beneath it, the body moves within a confined space, its flexibility reduced by the enclosure. The head extends forward through a limited opening, and the limbs operate within the constraints imposed by the surrounding structure. Some glyptodonts grow to considerable size. Dodicurus clavicaudus, among the largest, reaches a mass of around 1.5 tons. At the end of its tail, a structure forms that echoes a much earlier design. A rigid shaft supports a club covered in protrusions, capable of delivering force through lateral movement. The similarity to the tail weapon of distant reptilian forms is not inherited, but arrived at independently, a repeated solution emerging under comparable conditions. The shell of the glyptodont differs in its rigidity. It does not flex or shift in sections. It remains fixed, providing consistent protection while limiting the range of motion available to the body. Turning is restricted. The head cannot rotate freely, and the ability to adjust posture is reduced. The animal becomes defined by its enclosure, its movements shaped by the boundaries it carries. Within these environments, predators evolve that interact with this structure in different ways. Large flightless birds, reaching heights of several meters, move across the landscape with strong legs and hooked beaks, capable of delivering concentrated strikes. Later, as continental connections form, mammals from other regions enter these ecosystems. Saber-toothed cats and large bears introduce new forms of predation, each bringing different methods of interaction. The glyptodont persists through these changes. Its shell resists direct force, its size deters many approaches, and its presence remains stable across long intervals. Yet within the final portion of its existence, another interaction begins to appear in the record. Bones of glyptodonts found in parts of South America carry marks that do not match the patterns of animal predation. The cuts are precise, linear, and consistent with tools. They indicate removal of flesh, separation of tissue, systematic processing. These marks appear alongside evidence of early human presence, placing the two within the same environments. In some locations, the shells themselves show signs of use beyond the body that once carried them. Their curved forms, rigid and intact, provide coverage that can be repurposed. The structure that once functioned as protection becomes a surface that can shelter something else entirely. The development of glyptodont armor represents a return to extensive external protection within a mammalian lineage, refined across millions of years under stable conditions. Its persistence through multiple ecological changes suggests a system that functioned effectively within its environment. Yet the interactions recorded in its final remains indicate a shift in how that environment operates. Across the closing stretch of the Pleistocene, a quiet thinning begins, not in a single instant, but in a sequence of disappearances that move across continents like a slow, deliberate tide. Between 50,000 and 10,000 years ago, large animals vanish from the record with a pace that stands apart from the rhythms seen before. The change does not resemble the drawn-out collapses of ancient oceans or the chemical shifts of distant eras. It unfolds more abruptly, more locally, yet with a consistency that repeats across separate landscapes. In South America, the glyptodonts persist until roughly 10,000 years ago. Their remains appear in layers that also contain traces of newly arrived human populations spreading through the continent after crossing from the north. In the same intervals, pamphithers, large armored mammals, shaped like elongated relatives of armadillos, disappear alongside them. The pattern is not isolated to a single valley or region, but occurs across wide areas where both groups had previously been stable. The armor these animals carried had been shaped by millions of years of interaction with predators that relied on direct physical force. Teeth pressed against bone, claws met hardened surfaces, weight collided with resistance. Within that framework, the carapace functioned as intended, dispersing energy, preventing penetration, and turning attacks aside. Against such methods, a fully grown glyptodont presented a form that few animals could meaningfully damage. Yet the pressures arriving with humans operate along a different axis. The tools introduced into these encounters extend reach beyond the immediate body. A thrown spear delivers force from a distance, bypassing the need to grapple directly with the shell. Points of entry exist where movement must occur, at the junctions of limbs, at the base of the neck, along the lower edges where armor cannot fully seal without restricting motion. These openings, once small compromises within an otherwise secure system, become focal points when targeted deliberately. Coordination adds another layer. Multiple individuals acting together can influence the position of a much larger animal, guiding its movement, restricting escape, applying pressure from several directions at once. An animal that relies on its own mass and protection finds itself responding to a distributed presence rather than a single attacker. The ability to surround changes the geometry of the encounter. In such situations, posture becomes critical. If balance is disrupted and the body is overturned, the surface that was least protected becomes fully exposed. The underside, shaped for flexibility and internal function, cannot withstand the same forces as the dome above. What had been a secondary vulnerability, rarely accessed by earlier predators, becomes central under these new conditions. There is also a quieter element within these interactions, one that does not leave marks in bone. Large armored animals evolved in environments where their defense reduced the need for constant vigilance. Their movements, their routines, their responses were shaped by threats that operated within familiar limits. When those limits shift, the existing behaviors do not immediately adjust. The result is not a failure of structure, but a mismatch between structure and circumstance. The shell remains strong, the body remains capable within its inherited design, yet the nature of the challenge no longer aligns with the conditions that shaped that design. The disappearance that follows is recorded not through a single dramatic boundary, but through the gradual absence of forms that had once been widespread. Among all the endings traced across this long narrative, this one carries a different quality. The cause is not embedded in distant geological processes or planetary changes, but within a species that continues forward, still present, still altering the conditions around it. Patterns begin to echo across time in ways that do not rely on memory, as if the living world keeps arriving at the same shapes through entirely separate journeys. These recurrences are not copies passed down through ancestry, but independent constructions assembled under similar pressures, guided by the quiet constraints of bodies that must endure while still remaining alive in motion. In one age, heavy reptiles move close to the ground, their backs formed into rigid domes, their limbs spread wide for stability, their tails ending in weighted structures capable of delivering force. Much later, in a different era and on a different continent, mammals take on nearly identical proportions. Ankylosaurs and glyptodonts stand separated by tens of millions of years and by a boundary that erased entire ecosystems. Yet their silhouettes align with a precision that feels almost deliberate. Both settle into low profiles, both distribute mass outward for balance, both transform the tail into a controlled extension of impact. Further back, within ancient seas, distinct lineages of early vertebrates develop protective structures that cover the head and forward body in articulated plates. Placoderms and ostracoderms do not share a direct armored ancestor, yet both arrive at the same solution, a segmented shield that preserves mobility while guarding critical regions. The form appears, disappears, and appears again, shaped by the same underlying requirements of feeding, sensing, and surviving contact. In shallow coastal waters of a later period, reptiles begin to broaden their ribs and reinforce their dorsal surfaces. Some become turtles, their skeletons reorganized into complete enclosures, while others, the placodonts, evolve flattened armor suited to similar environments. These designs arise independently, yet both respond to the same balance between buoyancy, protection, and feeding along the seafloor. On land, smaller mammals develop overlapping coverings composed of hardened scales or plates. Pangolins in Africa and Asia, armadillos in the Americas, separated by geography and lineage, both arrive at a strategy that allows the body to curl inward, presenting a continuous surface to the outside while concealing softer regions. The materials differ in detail, but the principle remains consistent, a flexible armor that transforms posture into defense. Even among invertebrates, repetition emerges. Trilobites, horseshoe crabs, and woodlice each display a segmented, domed upper surface paired with a more flexible underside. The arrangement appears in organisms separated by vast spans of time and by distinct evolutionary paths, yet the structure converges toward the same balance between rigidity and necessary movement. These recurrences point toward a deeper constraint, one not tied to lineage but to possibility itself. The forms available to a body that must protect itself while still bending, feeding, and reproducing, are not infinite. Within that limited space, certain configurations provide stable solutions. These configurations act like attractors, regions toward which evolution is drawn when similar challenges arise. When pressure repeats, form follows. The repeated emergence of armor across unrelated groups suggests that the concept is embedded not only in biology, but in the physical rules that govern stress, leverage, and motion. A curved surface distributes force. A low center of gravity resists tipping. Segmentation allows flexibility without complete exposure. These principles do not change with time, and so the shapes they produce return again and again. Across hundreds of millions of years, armor is assembled, refined, and lost, then assembled again in new bodies under new skies. The persistence of these designs does not depend on continuity of species, but on continuity of constraint. Life encounters familiar problems, and in answering them, it rediscovers familiar forms, each iteration slightly altered, yet recognizably aligned with those that came before. Far below the shifting climates and restless surfaces of the continents, there is a realm where change slows to a near standstill. Light does not reach this depth, and the rhythms that govern life above lose their urgency. Pressure remains constant, temperature holds steady, and the absence of seasons removes the pulses that drive rapid adaptation. In this vast expanse, stretching beyond 200 meters and covering more than half of the planet, forms persist with a quiet continuity that reaches back into distant ages. Within these waters, bodies appear that would not seem unfamiliar in strata laid down hundreds of millions of years ago. The horseshoe crab moves along the seafloor with a shape that has endured since the Ordovician, its rounded shield covering the front of its body in a smooth curve that deflects contact from above. Its tail spine extends behind, not as a weapon, but as a lever, allowing it to right itself when overturned. The design has required little alteration, its effectiveness preserved by an environment that asks no new questions of it. Inside this animal flows a different chemistry, a copper-based blood that carries oxygen with a blue hue. Within that fluid is a sensitivity so precise that it reacts instantly to the presence of bacterial toxins. This property has found a place in human systems, where extracts are used to ensure the safety of medicines and implants. A lineage shaped in ancient seas now contributes, indirectly, to the protection of lives in settings it will never encounter. Deeper still, near vents where mineral-rich fluids emerge from the seafloor, another form carries armor of a different kind. The scaly foot snail incorporates iron sulfide into its exterior, building a layered structure composed of a hardened outer surface, an inner calcite layer, and between them a zone that absorbs impact. The materials arise directly from its surroundings, integrated into its body through processes that bind geology and biology together. The result is a composite that distributes stress in ways that have drawn attention from those seeking to understand resistance to force. Elsewhere in the same darkness, the giant isopod drifts across the sediment, its body divided into overlapping plates that curve over one another. The segments allow movement while maintaining coverage, a familiar solution carried forward into a modern context. Its scale is larger than many of its relatives, yet its structure remains consistent with patterns established long before the present era. There are also fish that seem to have stepped out of another time. The coelacanth, once known only from fossils, continues to inhabit deep marine environments, its fins moving in a manner distinct from most modern fish, its scales retaining characteristics associated with earlier forms. Its rediscovery revealed not a new design, but the persistence of an old one maintained in conditions that did not require it to change. In these depths, armor does not vanish, nor does it struggle to justify its presence. It exists within a setting where stability reduces the need for constant adjustment, where the balance between protection and cost remains aligned with available resources. The pressures that once shaped entire dynasties continue here in a muted form, allowing certain solutions to endure without modification. The surface world has shifted repeatedly, climates altering, ecosystems collapsing and rebuilding, new forms rising and others fading. Yet beneath it all, in the quiet pressure of the deep ocean, the patterns of earlier ages continue, not as remnants, but as active participants in a system that has remained largely unchanged. In the quiet understory of forests and along the edges of grasslands, a small mammal moves with a deliberate, almost measured pace, its body covered not in fur, but in overlapping plates that catch faint light in soft reflections. It does not resemble the heavy armored forms of earlier ages, yet the principle it carries is unmistakable, a surface built to resist, to deflect, to endure contact without yielding. The pangolin exists today in 8 distinct species, spread across regions of Africa and Asia, each adapted to its own landscape, yet united by a shared design. Its scales are composed of keratin, the same material that forms human fingernails, arranged in layers that overlap like carefully placed tiles. They cover nearly the entire body, leaving only the face, the underside, and the inner limbs exposed where movement must remain unrestrained. When threatened by natural predators, the response is immediate and complete. The body curls inward, spine flexing, tail wrapping around until the animal forms a compact sphere. Each scale shifts into alignment with its neighbors, creating a continuous surface without edges to grip or gaps to exploit. Large carnivores, capable of breaking bone and tearing flesh, find no purchase. Attempts to bite or claw meet a structure that disperses force outward, returning it to the attacker without opening. After repeated efforts, most predators disengage, leaving the form intact, untouched, and still. For millions of years, this defense has remained effective within the ecological systems that shaped it. The pangolin's movements, its feeding on ants and termites, its solitary habits, all fit within a framework where its armor resolves encounters without escalation. It does not rely on speed, nor on aggression, but on the certainty that when contact occurs, its body can endure. Yet, beyond those systems, a different set of pressures has emerged, ones that do not interact with the animal in the ways its armor anticipates. Across the past decade, an estimated 1 million individuals have been removed from the wild, making the pangolin the most trafficked mammal on Earth. Its scales, valued in certain forms of traditional medicine, despite containing no compounds beyond those found in human keratin, have become the focus of a global demand. In this context, the qualities that once ensured survival become points of vulnerability. The act of curling into a ball, so effective against teeth and claws, offers no resistance to capture. A wire snare tightens regardless of the position of the scales. A tranquilizer enters through the unprotected regions that must remain flexible. Containment removes the possibility of escape entirely, rendering the protective structure irrelevant. There is a stark alignment between what the pangolin carries and what is taken from it. The same scales that turn aside the efforts of predators are the material sought by those who remove it from its environment. Protection becomes the reason for pursuit, and the defense that evolved over tens of millions of years becomes intertwined with the cause of decline. In this way, the pangolin situation does not stand apart from the broader pattern traced through earlier eras. It reflects a continuity of circumstance, where changes in the surrounding world alter the balance between protection and vulnerability. The form remains effective within the conditions that shaped it, yet those conditions are no longer the only ones it must navigate. The presence of the pangolin today, moving quietly through its habitat, carries within it both the persistence of an ancient strategy and the weight of pressures that extend beyond that history, unfolding within the same ongoing narrative. In laboratories far removed from forests and oceans, fragments of ancient design are examined under magnification, their patterns translated into equations, their structures measured not for what they once protected, but for how they achieved it. The record left behind by armored life has become a quiet archive, one that engineers and materials scientists read with increasing attention, tracing solutions that emerged long before human tools existed. Within the layered interior of mollusk shells, a structure known as nacre reveals itself as more than a simple mineral deposit. Though composed primarily of calcium carbonate, a material that fractures easily in isolation, its arrangement transforms its behavior. Thin plates are stacked in a staggered pattern, bound together by organic layers that absorb and redistribute stress. When force is applied, cracks are redirected sideways, forced to navigate a complex path rather than passing straight through. This deflection dissipates energy, allowing the structure to endure impacts that would shatter a uniform material. Replicating this arrangement has led to ceramics that resist fracture in ways once thought unattainable. A similar principle appears in the conch shell, where the internal architecture forms a cross-lamellar pattern, each layer oriented differently from the one before. When stress enters the structure, it is divided across multiple directions, its progress slowed at every boundary. The result is not absolute hardness, but controlled resistance, a capacity to absorb and distribute force rather than simply oppose it. Designs inspired by this pattern are now applied in materials intended to withstand blasts and repeated impacts, extending durability through structure rather than mass. In deeper waters, the layered protection of the scaly foot snail offers another variation. Its outer surface incorporates iron sulfide, forming a hardened exterior that meets incoming force. Beneath it lies a region that compresses slightly, acting as a buffer, followed by an inner layer that maintains shape. This combination of hardness, flexibility, and rigidity within a single system has influenced the development of protective equipment that must balance resistance with energy absorption. Living fish also carry echoes of earlier solutions. The alligator gar bears scales composed of ganoin, an enamel-like substance that forms a tough outer coating over a flexible base. The scales overlap, allowing the body to bend while maintaining coverage. This integration of mobility and protection is studied in efforts to create materials that move with the structures they defend, rather than restricting them. The dome of the turtle shell offers guidance at a larger scale. Its curved geometry spreads compressive forces evenly, preventing stress from concentrating at a single point. This principle extends beyond biology into the design of helmets, architectural forms, and vessels intended to withstand pressure from all directions. The shape itself becomes a mechanism of protection, independent of the material from which it is made. Even bone, present in countless armored forms, reveals a hierarchy of organization. From microscopic collagen fibers to larger structural units, each level contributes to overall strength while limiting weight. This layered complexity informs the creation of composites that seek to combine lightness with resilience, an ongoing pursuit in fields where efficiency and endurance must coexist. Human attempts to design armor span only a small fraction of the time over which these natural systems developed. The difference in accumulated refinement is vast, reflected in the subtlety of structures that evolved without intention, shaped only by survival across changing conditions. What emerges from this comparison is not a sense of replacement, but of translation, a process of learning from forms that have already endured countless tests. The materials being developed now carry within them echoes of shells, scales, and bone, not as direct copies, but as interpretations of underlying principles. In studying these structures, a connection forms between distant pasts and present efforts, where solutions once embedded in living bodies are reimagined within human design. Seen from a different angle, armor becomes less a shield and more a document, a surface that records the pressures that shaped it. Each ridge, each thickened plate, each hinge or seam exists not in isolation, but as a response to forces applied again and again over long spans of time. In this way, the body of an armored animal carries within it a quiet account of the predators it encountered, preserved not in words, but in structure. In early armored fish, such as Dunkleosteus, the distribution of protection reveals the direction from which danger most often arrived. The heaviest plates concentrate around the head and the forward body, forming a reinforced front that could absorb impact during direct encounters. Toward the rear, the coverage becomes lighter, suggesting that threats rarely approached from behind in the same manner. This arrangement aligns with a world in which large predators met one another face to face, their interactions governed by forward momentum and immediate force. Elsewhere, the bodies of trilobites contain a different kind of record. Many species developed the ability to fold into a compact form, their segments aligning to create a continuous outer surface. In some, this behavior became highly refined, with small projections along the edges that interlocked when the body curled. Such precision indicates repeated pressure from predators that applied force by squeezing, attempting to open the body through compression rather than puncture. The locking mechanism resists that action specifically, holding the form closed against sustained pressure. On land, the armor of nodosaurs presents another pattern. Around the neck, a series of reinforced rings protects the junction between head and body, an area that must remain mobile yet vulnerable. The concentration of material here suggests that attacks frequently targeted this region, likely delivered from above and accompanied by twisting motions. The structure counters that movement, stabilizing the connection and dispersing force across a broader area. Across successive layers of Devonian rock, changes in placoderm armor can be measured with increasing precision. Thickness rises incrementally, plate boundaries shift, and joint structures become more robust. These changes do not occur randomly, but in parallel with the appearance of larger and more capable predators within the same environments. The correlation forms a timeline, a gradual escalation in which each adjustment reflects a corresponding increase in the forces applied by opposing forms. The tale of ankylosaurs offers a similar sequence. Early members of the group possess elongated tails with modest reinforcement, while later species develop expanded, heavily ossified clubs at the end of a stiffened structure. The internal architecture becomes denser, capable of transmitting greater force. This progression aligns with the emergence of larger predatory dinosaurs, suggesting a coevolution in which defensive and offensive capabilities rise together, each influencing the other across generations. Direct evidence of these interactions appears in the marks left on preserved surfaces. Tooth impressions on armor plates can be analyzed for spacing and depth, allowing identification of the predator responsible. The location of these marks reveals where attacks were focused, while patterns of healing or absence thereof indicate whether the encounter was survived. In some cases, incomplete penetration shows where armor successfully resisted, leaving behind a trace of an attempt that did not succeed. Taken together, these features form a continuous exchange, a dialogue carried through form and counterform, through pressure and response. Armor reflects predation, and predation reflects armor, each shaping the other within the limits of physics and biology. The record that remains is not one of dominance by a single side, but of balance maintained through constant adjustment, a long conversation etched into the bodies of those that endured. At a certain point in this long unfolding, the pressure shaping armor no longer comes only from teeth or claws, but from something less visible, a shift in the way danger is applied. The surface of a shell or plate still meets force, still absorbs impact, yet the nature of that force begins to change in ways the material cannot anticipate. For most of Earth's history, predation remains immediate and physical. A body strikes another body, and survival depends on resisting that contact. Armor answers this clearly, turning aside bites, dispersing pressure, transforming a direct encounter into a failed attempt. The exchange is simple in structure, even when complex in execution, a meeting of force against resistance. Gradually, a different pattern emerges. In the late Permian, predators begin to move not only toward prey, but after it, sustaining motion across distance. The gorgonopsids embody this shift, their bodies shaped for endurance as much as impact. They do not rely solely on overpowering what they meet, but on following, selecting moments when the body reveals openings through movement. Armor, designed for the instant of collision, finds itself responding to a sequence instead, a chain of actions unfolding over time. This pattern deepens in the Cretaceous. Large theropods show signs of behavior that extends beyond solitary attack. Their fossil traces suggest coordination, a distribution of roles within a group, and an attention to particular regions of the prey body. The interaction becomes less about where contact happens by chance and more about where it is guided to occur. Armor still functions, still prevents penetration, yet the attack is no longer confined to the first point of contact. It adapts, circling, pressing at edges, seeking the transitions between protected and unprotected surfaces. Even within this change, the encounter remains grounded in the physical. The predator must still reach the prey, must still apply force through its own body. Armor can still respond within those limits, shaping itself around likely points of impact, thickening where pressure is greatest, allowing flexibility where movement demands it. Then, within a comparatively brief span, another threshold is crossed. A form of predation appears that does not depend on the immediate capabilities of the body alone. It carries within it the ability to anticipate, to construct sequences before they occur, to alter the conditions of the encounter itself. The human lineage introduces a mode of interaction in which the prey is not only met, but studied, its behavior inferred, its responses predicted. In this context, armor encounters a kind of pressure it was never structured to address. A shell can resist a bite, a plate can deflect a strike, yet neither can prevent an action that changes the orientation of the body entirely. A predator no longer needs to overcome the strongest surface if it can reposition the animal so that a weaker surface is exposed. The relationship between force and defense becomes indirect, mediated through planning rather than immediate contact. Tools extend this further. Objects shaped outside the body carry force to places the body itself cannot easily reach. Distance becomes less relevant, timing becomes adjustable, and the encounter unfolds across intervals rather than in a single moment. Armor, which evolved to meet force at the boundary of the body, finds that the boundary itself is no longer the only point of engagement. In this quiet shift, the long conversation between predator and armor changes its structure. The pressures that once shaped thickness, curvature, and articulation begin to include factors that cannot be answered by material alone. The surface remains. The plates still interlock, yet the conditions around them have altered, and the response required moves beyond the reach of bone and scale. In the quiet spaces that remain, far from the crowded centers of modern ecosystems, armor still persists, not as dominance, but as endurance, shaped into habit. The creatures that carry it now do so in ways that feel restrained, almost deliberate, as though each movement has already been negotiated with the cost of carrying such protection. On isolated volcanic islands in the Pacific, the Galapagos giant tortoise moves with a patience that seems detached from urgency. Its body stores energy slowly and releases it even more slowly, allowing months to pass with minimal intake. The shell above it forms a continuous arch, a structure that distributes pressure evenly across its surface while shielding the organs beneath. Within this enclosure, time itself becomes part of the defense, stretching life into spans that exceed 170 years, where survival is less about reacting and more about enduring. Across warmer continental margins, the nine-banded armadillo follows a different rhythm. Its armor is not a single dome, but a series of overlapping bands, flexible enough to allow sudden bursts of motion. It moves through varied terrain, crossing rivers by altering its body in unexpected ways, sometimes walking along submerged ground, sometimes adjusting buoyancy through air held within. The protection it carries is paired with behavior that adapts quickly, allowing it to enter regions where other armored mammals would struggle to persist. In waterways that blur the boundary between land and river, crocodilians rest at the surface with only minimal movement. Their bodies retain a form established tens of millions of years earlier, yet their survival depends on restraint. They can reduce their metabolic demands to levels that allow long intervals without feeding, remaining still until conditions align. The osteoderms embedded within their skin serve multiple roles, dispersing force while also participating in thermal exchange, linking protection with the regulation of energy itself. Along shorelines shaped by tides, the horseshoe crab follows cycles that have repeated across immense spans of time. Its domed exterior resists both mechanical stress and the few predators capable of overcoming it. When it reproduces, it does so in numbers that shift the balance of survival away from the individual and toward the collective. The vulnerability of its eggs is answered not through stronger protection, but through overwhelming abundance, a strategy that complements the durability of the adult form. Across all of these lives, a pattern becomes visible, not through repetition, but through alignment. Each lineage that continues to carry armor does so alongside a way of living that reduces demand, narrows exposure, or adjusts behavior in response to changing conditions. The protection itself remains effective, yet it is no longer sufficient on its own. It is part of a broader system that balances cost and survival in environments where excess cannot be sustained. What is no longer present among them is equally revealing. There are no vast herds of heavily armored bodies moving across open plains, no large forms dependent on constant intake, no widespread dominance built on protection alone. The spaces those creatures once occupied are now filled by animals whose strategies rely on speed, coordination, or cognition, shifting the balance of survival toward different traits. The survivors that remain do not appear as remnants of a former age, but as organisms that have narrowed their existence to conditions where their design still aligns with the world around them. They persist by remaining within boundaries that suit them, holding to places where the cost of their protection can still be met, and where the pressures that shape them have not entirely disappeared. A layer of stone, no thicker than a hand, can contain the rise and disappearance of entire worlds. Within such layers, compressed into mineral and silence, are spans of existence that extend far beyond any duration that can be held in ordinary thought. The record does not announce endings. It simply stops, and in that absence, an entire lineage becomes something that once was. The trilobites endured for 270 million years, a continuity so vast that it stretches beyond comparison with anything familiar in the present. Their forms shifted, diversified, refined, yet the underlying design persisted through cycles of change that would erase countless other lineages. Then, at a boundary that marks a transformation in the planet itself, they vanish completely. No descendant carries their structure forward. No fragment of their design continues in altered form. The long arc closes without leaving a trace in the living world. The placoderms, whose presence once filled entire seas, followed a similar path. Their armored bodies defined the waters they inhabited, shaping interactions and establishing patterns that endured for immense spans of time. When they disappear, the lineage does not taper into smaller remnants or transform into recognizable successors. Instead, it dissolves, leaving behind only distant relationships at the level of shared ancestry, connections so abstract that the original form becomes unrecognizable within them. Much later, in a different configuration of continents and climates, the glyptodonts move across open ground with a stability that suggests continuation. They persist through environmental shifts, through the arrival of new predators, through the merging of previously separate landmasses. Yet their disappearance unfolds within a span so brief that it compresses into a thin horizon in the geological record. The duration of their existence, measured against the scale of deep time, contracts into a moment that passes almost unnoticed. All of these sequences unfold long before any observer is present to witness them. The transformations that shape entire eras occur without memory, without record, beyond the structures that remain embedded in rock. The appearance of human awareness arrives after these events have already concluded, entering a world that carries the results, but not the experience, of what came before. The span of written thought, from its earliest marks to the present, occupies only a minute fraction of the time during which armored life shaped the planet. The accumulation of knowledge, language, and reflection, vast as it seems within its own context, remains confined to an interval so brief that it barely registers within the broader sequence of Earth's history. The perception of continuity that arises within this interval is shaped by its own limits. From the perspective of geological time, the present arrangement of life does not settle into permanence. It exists as one configuration among many, a temporary alignment of forms that will, in turn, give way to others. The creatures that once dominated earlier ages were not incomplete versions of what would follow. They were fully adapted to the conditions of their time, occupying roles that were as stable and as enduring as anything that exists now. Their absence does not suggest failure, but transition. Entire systems can persist for spans that seem immeasurable and still come to an end without leaving a direct continuation. In this way, the history of armored life becomes not only a record of adaptation, but a reminder that duration, no matter how vast, does not confer permanence. Long before the shapes of shells and plates settle into stone, they exist as decisions carried through living bodies, repeated across generations that never pause to reflect on what they inherit. Each layer, each ridge, each reinforced edge emerges not as a design in isolation, but as the continuation of a line that has persisted without interruption. What remains visible in the fossil record is only the outer surface of something far deeper, a continuity of survival that stretches backward beyond any single form. Every armored creature that appears in this story stands at the end of such a chain. Its structure carries the imprint of countless moments in which its ancestors endured encounters that might have ended differently. The thickness of a cranial plate, the curvature of a dome, the placement of a spine, each of these features corresponds to pressures that once existed as immediate events. Over time, those events accumulate, and their outcomes settle into the body itself. A placoderm's head shield, dense and unyielding, reflects not a single encounter, but a sequence of interactions in which force met resistance and did not prevail. Each increment of reinforcement represents a lineage that continued because the barrier held. Across generations, these increments gather, shaping a surface that embodies the persistence of those that carried it before. In a different lineage, the weighted end of a tail becomes more than a structure for movement. It forms through repeated proximity to threat, through moments in which distance closed and contact became inevitable. The mass and configuration of such a feature record the narrowing margin between safety and exposure, refined until it can respond within that brief interval where outcome is decided. Elsewhere, the presence of pigmentation and patterning adds another dimension to this record. Color, distributed across a body in gradients and contrasts, aligns with the conditions under which visibility becomes a factor in survival. These patterns emerge not as decoration, but as a response to being seen, shaped by interactions in which detection altered the course of events. They suggest that even when surfaces are reinforced, other forms of response continue to develop alongside them. In this way, armor extends beyond material composition. It becomes an accumulation of responses to specific kinds of pressure, preserved in physical form. The body carries forward not only the immediate function of protection, but also the history of conditions that made such protection necessary. Each feature persists because it aligned, at some point, with circumstances that allowed continuation. When these forms are preserved in rock, they appear as static objects, detached from the processes that shaped them. Yet, within their structure lies the record of countless interactions, each contributing to the configuration that remains. The fossil does not display these moments directly, but it retains their outcome, encoded in proportion, thickness, and arrangement. Seen in this light, the long sequence of armored life becomes more than a catalog of forms. It becomes a continuous archive of adaptation, in which each body carries forward the results of what came before. The materials themselves, whether mineral or organic, serve as the medium through which this continuity is expressed, linking one generation to the next without interruption. What persists across this span is not only the presence of armor, but the process by which it is shaped. That process continues wherever conditions align in similar ways, producing structures that reflect the same underlying pressures. The record remains open, extending forward as well as back, held within bodies that still carry these accumulated responses into the present. There is a quiet weight carried by every protective structure, a consequence that settles into form long before it becomes visible as limitation. The surface hardens, the plates thicken, the edges interlock, and with each refinement, the body becomes more certain of what it is and less capable of becoming something else. Protection does not arrive alone. It brings with it a narrowing of paths, a commitment written into structure. In the great armored bodies of the past, this commitment can be traced through movement itself. A creature built to resist force from above develops a stance that favors stability over speed, a center of mass held low, limbs arranged to support weight rather than accelerated. Such a body becomes exceptionally capable within a specific range of conditions, yet that same design reduces its ability to respond when those conditions shift. The protection that once absorbed impact also shapes how the body can move through its environment, defining both strength and constraint. In another lineage, the continuity of a protective form becomes so refined that variation diminishes. Over immense spans, the structure stabilizes into an arrangement that leaves little room for alteration. This stability allows the lineage to persist through many changes, yet it also reduces the capacity to diverge when confronted with pressures that fall outside the range it was shaped to meet. The body holds to what has worked, even as the surrounding conditions begin to move beyond it. There are also forms in which protection alters interaction with the world in more subtle ways. A body that is consistently shielded from harm may develop patterns of behavior that assume that protection will always suffice. Movement becomes more predictable, responses more consistent, as the need for rapid adjustment diminishes. When new kinds of pressure arise, this predictability can become a point of exposure, not because the structure fails, but because the context around it has changed. In contrast, other lineages follow a different path, one in which protection is reduced or distributed differently. Their bodies remain lighter, their forms less specialized, allowing for a wider range of responses. They move more quickly, reproduce more rapidly, adjust more readily to variation in conditions. The absence of heavy protection introduces immediate vulnerability, yet it also opens possibilities that are not available to more constrained forms. Across these divergent paths, a balance emerges, not as a fixed point, but as an ongoing adjustment between opposing demands. To invest heavily in protection is to secure the present at the expense of flexibility, while to invest in adaptability is to accept exposure in exchange for the ability to change. Neither path offers permanence. Each represents a different way of negotiating uncertainty. This balance extends beyond any single lineage. It appears wherever systems must persist in the face of shifting pressures, shaping the structures that emerge and the trajectories they follow. The forms that endure are those that align, for a time, with the conditions they encounter, carrying within them the imprint of the choices that led to their configuration. As the record of armored life unfolds, it reveals not a single solution, but a series of adjustments, each tuned to a particular set of circumstances. The shell, the plate, the reinforced surface, all represent answers that held for long spans, yet each also marks a boundary, a point beyond which a different kind of response becomes necessary. It is possible to stand in the present and still be surrounded by forms that carry the deep past within them, bodies that have persisted through transformations so vast they defy ordinary comparison. These organisms move through a world that has changed around them many times, yet their structures remain recognizable, holding to patterns established long before the current arrangement of continents and climates. In the open ocean, The leatherback sea turtle travels across entire basins, following currents that shift slowly over time. Its body, unlike other turtles, lacks a rigid shell, yet beneath its skin lies a network of reinforced plates that provide both protection and flexibility. It dives to depths where light does not reach, maintaining a physiology adapted to conditions that would challenge most vertebrates. Despite this resilience, its path intersects with materials and structures that did not exist in earlier eras, objects that persist in the water without dissolving, altering feeding and movement in ways its lineage has not encountered before. Across forested landscapes and fragmented habitats, the pangolin continues its quiet, nocturnal movements. Its overlapping scales form a defense that has proven effective against natural predators, allowing it to withdraw into itself when threatened. This response remains unchanged, yet the conditions surrounding it have shifted, introducing pressures that do not engage with the body in the same way. The continuity of its form persists alongside a changing context that does not align with the strategies it carries. In freshwater systems that once supported large and stable populations, the remaining giant softshell turtles occupy spaces that have become increasingly limited. Their bodies, broad and flattened, are adapted for life along riverbeds where they can remain concealed beneath sediment. The environments they depend on have altered in structure and flow, introducing variability that extends beyond the range their behaviors evolved to accommodate. The presence of only a few individuals reflects a narrowing of conditions in which such forms can continue. Along tidal zones and coastal margins, the horseshoe crab follows reproductive cycles that have repeated across immense spans of time. Its spawning events coincide with lunar patterns, producing concentrations of eggs that have historically supported complex ecological relationships. These cycles continue, yet the surrounding systems that once aligned with them have been modified, changing the balance between reproduction and survival. The organism persists, but the context that sustained its abundance has shifted. Within river systems of the Indian subcontinent, the gharial maintains a form distinct among crocodilians, its elongated snout specialized for a particular mode of feeding. Its osteoderms remain embedded within its skin, providing protection while allowing for streamlined movement through water. The habitats it requires have become segmented, altering the continuity of the environments that once supported its distribution. Its persistence now depends on conditions that are increasingly specific and limited. Each of these organisms carries a lineage that extends through multiple periods of transformation, enduring events that reshaped entire ecosystems. Their structures reflect solutions that aligned with those earlier conditions, allowing them to persist where others did not. The pressures they now encounter differ in kind as well as in scale, introducing variables that fall outside the patterns to which their bodies are adapted. The present moment holds these lineages within it, not as remnants detached from the past, but as continuations that remain active and responsive within their environments. Their persistence is not guaranteed, yet it is still unfolding, shaped by interactions that extend beyond the structures they carry. Morning gathers slowly over a field of dark volcanic stone, the surface still holding the night's coolness as light begins to settle across it. A Galapagos giant tortoise moves through this quiet, each step deliberate, its weight shifting with a steadiness that has no urgency. The curve of its shell catches the first warmth, the surface absorbing heat that will be held and released over hours, regulating a body that asks little and yields even less to haste. The geometry of that shell is not new. Its arch rises in a form that has persisted across spans of time so long they resist easy framing. Beneath it, ribs have broadened and fused, the spine joined into the structure above, creating a single continuous enclosure that has remained fundamentally unchanged since its emergence. The arrangement is both simple and exact, distributing pressure while enclosing the vulnerable parts of the body within a rigid boundary that moves as one. Inside this structure is a continuity that extends far beyond the individual animal. The developmental pathways that shape the shell follow patterns established deep in the past, linking this living form to earlier expressions of protection. Those connections are not visible on the surface, yet they persist in the organization of bone and tissue, in the way the body assembles itself from the earliest stages. Tracing that continuity backward reveals a sequence that passes through multiple worlds. It leads through river systems, where earlier turtles moved during periods of planetary change, their bodies already carrying the shell that would define them. It continues into a time when the structure was still forming, when ribs began to broaden and the arrangement of the skeleton shifted in ways not seen in other vertebrates. Further still, it connects to distant ancestors whose bodies carried different forms of protection, earlier experiments in reinforcing the boundary between organism and environment. Each stage in this sequence reflects conditions that shaped it, environments that selected for particular arrangements and allowed them to persist. The present form is not an endpoint, but a continuation, a configuration that has remained aligned with the conditions it encounters. The tortoise does not carry awareness of this continuity, yet its body embodies it, maintaining a structure that has endured through multiple transitions. Its movement remains unhurried, guided by rhythms that extend beyond immediate pressures. The energy it gathers is used slowly, its metabolism calibrated to sustain long intervals between feeding and activity. This balance allows it to occupy a niche where stability is maintained through restraint, where persistence is achieved not through rapid response, but through consistency. Around it, the environment shifts in subtle ways, light changing angle, temperature rising across the stone. The tortoise continues, its presence integrated into these changes without altering its pace. The shell remains the central feature, both protection and constraint, shaping how the body interacts with its surroundings. In this single animal, the long history of armored life is neither displayed nor concluded. It continues quietly, carried forward in a form that remains viable within its current context. The structure that defines it has endured not by dominating every environment, but by aligning with specific conditions that allow it to persist. The scene holds without resolution, the movement steady, the form unchanged, a continuation of patterns established long before this moment, still present within it. There is no single horizon where one age gives way to another, no clear seam in the world where a chapter closes and a different one begins. Instead, there are long gradients, quiet contractions, and the slow narrowing of possibilities. What once occupied vast, open systems withdraws, step by step, into places where the conditions that shaped it still hold. The change is not sudden. It is patient, almost imperceptible, unfolding across spans too large to feel directly. The lineage of Armour follows this kind of movement. It does not vanish in a single event, nor does it leave behind a clear absence. It shifts its ground. Forms that once moved through expansive environments become confined to margins, to spaces where stability remains. These spaces are not random. They are consistent in their predictability, in their resistance to rapid change, in the way they buffer the fluctuations that reshape other regions. Along coastlines, where the boundary between land and sea repeats itself in measured cycles, certain patterns persist. In depths where light does not reach and temperature holds steady, structures endure with little alteration. On isolated landmasses where ecological pressures remain contained, older configurations continue to function without needing to transform. These are not remnants in a diminished sense, but continuations aligned with conditions that still support them. The persistence of these forms suggests that the underlying principles that produce them have not disappeared. They remain embedded in the interaction between organism and environment, emerging wherever those interactions maintain a certain balance. The shapes may be familiar, the arrangements recognizable across distant intervals, yet their survival is not due to resistance alone. It is due to compatibility with the specific demands of the spaces they inhabit. Across the surface of the planet, the broader system has changed repeatedly. Atmospheric composition has shifted, ocean chemistry has altered, continental arrangements have reconfigured. Entire assemblages of life have appeared and receded, each replacing what came before with new combinations of form and function. Within this continual restructuring, some strategies persist not by dominating every context, but by finding those that remain stable enough to support them. The continuity of armor within these contexts is not a static condition. It is maintained through the same processes that shaped it originally, incremental adjustments within a framework that remains recognizable. The materials may differ slightly, the proportions shift, but the underlying arrangement continues to resolve the same set of constraints. Protection, movement, and resource use remain in balance within these bounded environments. What appears, from a distance, as disappearance is often redistribution. The prominence of a form may decline, its presence becoming less visible within the larger system, yet it continues within narrower ranges. These ranges act as reservoirs of earlier solutions, holding configurations that were once widespread and allowing them to persist alongside newer forms that dominate other spaces. Seen in this way, the age associated with armor does not conclude. It becomes less central, less expansive, but it remains active wherever the conditions that shaped it still apply. The narrative does not end, it shifts scale. It moves from the broad to the specific, from the dominant to the contained, without losing continuity. The present world carries these continuities quietly. They are not always apparent within the most visible systems, yet they are embedded within the fabric of the planet, sustained by environments that have changed less dramatically than others. In those places, the same principles continue to operate, linking the current moment to a much longer sequence without interruption. The result is not a clean boundary between what was and what is. It is a layered condition where multiple histories coexist, some more visible than others. Armor remains within this layering, not as an isolated relic, but as an ongoing expression of relationships that have persisted across deep time. A shell warms under a quiet sun, its surface holding the slow accumulation of elements that have traveled longer than any single life could contain. What appears as a single, complete form is in fact a gathering, a convergence of materials that have passed through oceans, stone, and living bodies across spans that do not announce themselves. The dome is not only structure, it is continuity shaped into something that can be carried. Within that curved surface, calcium, once dissolved in ancient water, has been taken up, released, and taken again, cycling through systems that no longer exist in their original form. It has moved through reef frameworks built by organisms whose names are now only patterns in rock, through sediment layers compressed by time, through plants that drew it from soil, and into the body that now holds it in place. Each transfer altered its context, but not its presence, guiding it toward another expression of the same enduring pattern. What we call armor is one arrangement among many, yet it preserves within its structure a record of pressures that shaped it, not as images or recollections, but as form, thickness where force once gathered, curvature where impact needed to disperse, articulation where movement could not be sacrificed. These features are not decorative, they are responses made durable, held in mineral and protein, carried forward without awareness yet never without meaning. The disappearance of earlier bodies did not remove these patterns from the world, it redistributed them. The substance that once defined edges and plates settled into stone, into the ground beneath present landscapes, becoming part of the foundation upon which later systems would rise. Other aspects traveled inward, becoming frameworks within bodies rather than coverings upon them, shifting position while retaining their function as support, as resistance, as structure. Even the most complete forms that have been sealed within rock are not entirely absent. Their shapes remain intact, where conditions allowed preservation, holding the arrangement of tissues, the spacing of plates, the texture of surfaces that once met the surrounding world. These preserved forms do not speak, yet they persist as configurations that can be read, offering a direct continuity between the moment of their existence and the present act of observation. Across these transformations, nothing has been lost in the absolute sense. It has been reorganized, incorporated into new contexts, aligned with new conditions. The conversation between living systems and the forces that act upon them continues through these rearrangements, expressed each time matter takes on a form that can endure, even briefly, within a changing environment. To recognize this is not to resolve the story, but to hold it. The materials remain, the patterns persist, the processes continue. Armor, in all its variations, is one articulation of that continuity, a way in which life has negotiated with its surroundings, leaving behind forms that can be traced, even when the organisms themselves are no longer present. In the quiet of this moment, what endures is not a single lineage or a single form, but the ongoing transformation of the same elements, shaped again and again into structures that meet the conditions of their time. The memory is not held in thought, but in matter, in the way it is arranged, in the way it responds, in the way it remains. And within that arrangement, carried without awareness yet always present, the long passage of forms continues to exist, not as a past that has ended, but as a process still unfolding.